My name is Rigoberto Advincula. I'm a governor's chair with the University of Tennessee Oak Ridge National Lab. I'm a chemist. I'm specifically a polymer chemist, and we work a lot on polymer materials used by the plastics industry, the automotive industry, the oil and gas industry as well. And today I'd like to share to you how we have used GC mass spec pyrolysis, in particular, working with Frontier Labs on some of the state-of-the-art characterization methods that we do. So, for example, imagine you have a analytical problem on an unknown sample or something that fails. What are the options you have as a chemist? Well, things that we usually look at includes infrared spectroscopy, Raman spectroscopy, NMR, and of course mass spec. But what we have found through the years with the technique using Pyrolysis-GC mass spec, in particular with Frontier Labs, is we're able to do much more with very little sample. And so it has enhanced the way we analyze samples, we reverse engineer, or we look at failure analysis of things related to the polymer or plastics industry. So one of the things that we do a lot is called 3D printing. It is a subset of what we call additive manufacturing, and we deal with thermosets, rubbers, and thermoplastics. One of the things that fail with 3D printing is the interlayer bonding, but we also deal with a lot of commercial filaments or raw materials that we don't know the additives and their action. So GC mass spec pyrolysis allowed us to reverse engineer some of these uh, materials and then determine what could be the cause of failure or an enhanced property. The things that involve the Frontier Lab system and method, for example, the thermal desorption analysis, the hard cut, and what we call um, single shot or double shot techniques, allows us to ramp samples, but also the analysis can be done on specific windows from volatiles to non-volatiles. And so it is a very unique technique that when we paired with NMR, IR, or Raman, gives us a very specific identification of composition, but also the number of additives and the types that were used during the manufacturing. So one of the unique techniques with the Frontier Lab system is we have a direct connection to the GC line with the microfurnace. This sits on top of the instrument, and we can even use a programmable system to have multiple samples. This is essential for reproducibility. One of the things that I grapple as a professor is some of the students do not produce reproducible results, and that is because of sample preparation in many ways, but also systematic error. This is easily solved by using the microfurnace technique, as well as the option to have a multiple cell sample loading through their programmable platform. The other thing of interest to us is how GC mass spec pyrolysis appends the way we can look at product development. So, for example, in our lab, we deal with a lot of composites. These composites can contain nanomaterials like graphene, nanoclay, different types of carbon nanotubes. And so we like to do the AI and machine learning methods to optimize their formulation and come up with the best property using algorithms or even a type of machine learning based on Bayesian optimization all the way to decision tree. In the future, we see GC mass spec pyrolysis being very important in formulation chemists or chemistries, whether it be in the university or even in industry, where they can use this technique to refine and validate their algorithms in terms of product development, and in our case, determining that structure, composition, and processing property relationship. Last, I'd like to say that this technique is very accessible. It is one of the things that you can use almost with any type of GC mass spec instrumentation. The barrier to it is low in terms of preparing samples, and I dare to say that there's no preparation needed for the sample itself for you to use this technique. So I hope in the future, many of you who are interested in this technique will explore it and find its utility, both research and in commercial or R&D projects. I'd like to thank you, and I'd like to thank Frontier Labs for this opportunity to work with them.